Ever wonder how we really learn the fundamental rules of math? Well, today, we're going to go back to basics. We're going to uncover the simple secrets to adding and subtracting fractions, and we're going to do it by looking at an actual fourth grade math module. So let's dive right in.
Seriously, think about it. The last time you cut a pizza into slices or measured out, say, a half cup of flour for a recipe, you were doing math. You probably didn't even realize it, but those simple, everyday things? Yeah, that's fractions in action.
See, you were using fractions and you probably weren't even thinking about it. So today, we're going to pull back the curtain and look at the simple rules that make it all click, and we're getting them straight from a teaching guide for young mathematicians.
Okay, section 1. First things first, let's meet the absolute stars of the show, similar fractions. I'm telling you, if you get this one concept, it's the key that unlocks everything else.
And the definition? It's super simple. Similar fractions are just fractions that have the same bottom number, the denominator. Just think of that bottom number as telling you how many equal slices the whole pizza is cut into. That's it.
And the module gives us this great little trick for remembering this. Think of them as members of the same family, right? They all share a common trait, they all come from the same whole, and are divided into the same number of pieces. That denominator they share, that's kind of like their last name.
And this chart here just lays it out perfectly. On the left, you've got fractions from the same family. 2/3 and 1/3, 3/6 and 1/6. They fit. But on the right, totally different families. A fourth is a completely different size slice than a sixth. You can't just add them together. It'd be like trying to add apples and oranges. It just doesn't work.
All right, so now that we know how to spot fractions from the same family, let's get into the simple rules of how to actually do the math. And trust me, this is where it gets really easy.
When you're adding these guys, it's so intuitive. It's just 2 steps. First, you add the top numbers, the numerators, because you're just counting how many slices you have in total, right? And then for step 2, you just copy the same denominator. The size of the slices isn't changing, so that bottom number stays exactly the same.
So, for example, let's say you have 2/5 of a candy bar, and your friend gives you 1 more fifth. All you do is add the tops. 2 plus 1 is 3. You now have 3/5. See? The size of the pieces, the fifths, never changed.
And here's the really cool part. Subtraction works the exact same way, just in reverse. Step 1, subtract the top numbers. Step 2, you guessed it, copy the same denominator. Again, the size of the slices doesn't change.
So let's go back to that candy bar. You had 3/5, and then you eat 1/5. You just do 3 minus 1 on top, which is 2. You're left with 2/5. It's that simple, consistent logic that makes this so easy to learn.
Okay, so the rules themselves are pretty simple, right? But how does this actually play out in a real problem? Let's take a look and see this whole thing in action. So here's a little story problem from the module. We've got a van driver, Kuya Rek, and he noticed that last month, 3/10 of his passengers wore face masks, but today, 7/10 of them wore. Now, what's the first thing you notice? Both fractions are tenths. They're from the same family.
So the first question for us is, what's the total fraction of passengers wearing masks that Kuya Rek drove? That word total is our big clue, right? That means we need to add.
Okay, so let's just use our simple rule. We take 3/10 plus 7/10. We add the top numbers. 3 plus 7 equals 10. And the bottom number just stays the same, so we get 10/10.
And what is 10/10? Well, that's 1. It's 1 whole. It means if you combined all the masked passengers from both trips, you'd have 1 complete group.
But the problem's not over. Now we have to ask, what's the difference between the 2 groups? And that word difference is our signal. It's time to use our subtraction rule.
So we take the bigger number, 7/10, and subtract the smaller one, 3/10. 7 minus 3 is 4, so the answer is 4/10. And hey, here's a little bonus step. We can actually simplify that. If you divide the top and the bottom by 2, you get 2/5. Both are technically correct, but 2/5 is what we'd call the simplest form.
So we've covered the what and the how. We know what similar fractions are and how to add and subtract them. But maybe the most important question of all is, why? Why do these rules work this way?
I mean, this is the question that takes you from just following rules to actually understanding math. Why is it so important for those denominators to be the same before you can add or subtract? Why can't you just add, 1/4 and 2/6 and call it a day?
Well, the answer is something we kind of already know deep down. You can't add one apple and one orange and say you have two apple oranges, right? It doesn't make sense. In fractions, that denominator, that's what tells you what kind of fruit you have. You have to be working with the same kind of part, the same family, before you can actually combine them.
And to wrap this all up, the module leaves us with this really powerful idea. This quote talks about how a body is one unit, even though it's made of many different parts. And that is a perfect metaphor for what a common denominator does. It creates that one body, that shared whole, that allows all the different pieces to come together and make sense. It's an amazing reminder that math, at its heart, isn't just about numbers. It's a language we use to understand how all the different parts of our world fit together into one unified picture.